In the next slide, children, okay, there is no need to go to this slide. There is not requirement of this slide also. I'm going to skip some slides, that these slides are according to other boards also, Indian boards also. For IGCSE, some parts of the slide you need to skip. And I'm looking to the next property, that is the conservation of charge. Yeah, this one. So our next property is conservation of charge. As the name suggests, children, that the conservation of charge means charge remains conserved. As already we discussed in grade 9 and grade 8, that the conservation of energy phenomena. Similarly, that the conservation of charge is also take place. Charge also remains conserved. Charge also remains conserved in nature. How we can explain that the conservation of charge, students? Is there any student who can explain that this property, conservation of charge, if we already discussed, you studied? Is there anyone, Callister, or other one, conservation of charge?
Charge cannot be eliminated.
Okay. Now let me explain. Okay, I think that you're not sure about this conservation of charge property. Let me show this diagram first. That first you can make a note of this definition. The law of conservation of electric charge states that for an isolated system, the net electric charge always remains conserved or constant. For an isolated system, children, net electric charge, this is the meaning, net electric charge. Net electric charge, it remains conserved or constant. For example, in this diagram, children, you can find we have an object A with few charges are given, 1, 2, 3, 4, 5 positive charges are there. Please look it in such a way, these are the positive charge. This is not a sign of multiplication, it's a positive charge. And on the body B, again, we have few positive charge, 1, 2, 3, 4, 5, 6, 7 charges are there. And on it, 5 charges are there. If I bring into contact, now that what is the total charge on this whole system? On this whole system, that the total charge is as per the additive property, you can add. The total charge will be 5 plus 7, that is 12 coulomb. Now they are bringing into contact. After their contact, both the bodies, both body A and body B, these are the metals actually. When we make a contact in between them, what will happen? Now see here, children. After their contact, now the charge on body A and B, they distribute themselves. They distribute the charge. How they have distributed the charge? Now you can see again. If we count the charge on body A, this is 1, 2, 3, 4, 5, 6. Now it is 6 coulomb. And on the other body, let's suppose 1, 2, 3, 4, 5, 6. 6 positive charge on the body A, 6 positive charge on the body B. I'm just taking a random example, that 6 coulomb, 6 coulomb. So then again, the total charge, still I can take the total charge after their contact, still it is 12 coulomb. Means before contact and after contact. Still the total charge on the system is remain constant. It is again 12 coulomb. So this property is called the law of conservation of charge. Even there is another example, best example. If you are unable to understand with this example, I want to give you one more example to explain this conservation of charge property. And for that, I want to stop sharing and I want to go to the white screen. I want this whiteboard. And students, let me take one example. Suppose I have this glass rod. And I will take another material. This is a silk cloth. Silk. This is a silk cloth. a cloth, piece of cloth, but made of silk material. Initially, you know that the glass rod is neutral. No, atoms and materials are neutral. They are neutral. Silk is also neutral, means positive electrons and protons are in the same number. They are neutral. Atom as a whole, it is neutral. But somehow, what we have done here, I have rubbed the glass rod with a piece of cloth, that is silk. So when I rub, then what will happen? Then this happens, that is a phenomena will take place, that one body will lose electrons and another body will acquire some electron. So I will take that this glass rod lose some electrons, and if it has lost some electron, then the glass rod becomes positively charged, and the silk cloth, that now the glass rod has lost some charge, then where this charge will go? Definitely that the silk cloth is in contact of the glass rod, because we have rubbed them with the concept of friction. So the negative charge means the silk cloth will acquire or gain the electrons from the glass rod. So then the same amount of negative charge will appear on the silk cloth. Now as a whole, this whole as a single isolated system, what is the total charge on this glass rod and silk pair? Again, you will find plus 3 and minus 3. Again, this is equal to 0 coulomb. That's still that the total charge on this system before rubbing and after rubbing. It is still before rubbing, the total charge was 0 as a neutral, and still as a system. You need to consider as a system, children, not individually. Individually, that the glass rod had 3 positive charge and the silk have negative charge. But as per the conservation phenomena, single isolated body you consider. So the system as a whole, still we have the total charge equal to 0 coulomb. So I want to go back to the same slide now, children. So after understanding the meaning of the law of conservation of charge, we want to move ahead. Yeah, you can read it here that the charges are transferred from object B to object A, but the total charge is always constant for the system. System means that the system of two bodies A and B. Before the contact, before making a contact, total charge was 7 plus 5 charges 12, and after contact still it is 12 positive charges are there on the system. So this example already discussed. I want to discuss one example from the nuclear physics, and you can find this example here that you have done some questions based on this concept in your chemistry classes about to make this equation balanced equation. In terms of charge conservation, I will take that before the reaction take place here, the total charge is you can say 92 electron. And once the reaction take place, means after the reaction here on the right hand side, if you do the total calculation here, and you will find still the 54 plus 38 plus 0, that sorry, the total charge is 92 before and after. In any nuclear process, in nuclear reactions, still the charges remains conserved. So that is the meaning of students for the conservation property. You please remember, conservation property states that whenever the charges are taking place, means transfer of charges are taking place, still the charge on a system as a whole, a single body, the charge remains constant or conserved.